actually start these notes, part 2. I'm not going to give you the homework associated with this yet, and we're only going to do part of this. The reason I'm only going to do part of it, I'm going to do the part that I think goes with today's lesson, naturally goes with today's lesson. So what's happening is this. We have seen, for example, the manufacturing example and the shipment example. We have seen that with type 1 and type 2 errors, particular groups benefit more from the occurrence of a particular type of error. Okay? For example, let's remember back to the shipment example that we just had on our notes part 1. So on our notes part 1, this is what was going on. Type 1 error was bad for the manufacturer because they would have to resend another shipment when the first shipment was actually acceptable. Okay, so type 1, they want to avoid, so the manufacturer wants to avoid, you don't have this written down, but I'm just kind of going through this, wants to avoid a type 1 error. Type 2 error was bad for you, the shipment manager of your company, because your company would be paying for faulty parts. So you want to avoid a type 2 error. All right. Look at how I switched up those things. A type 2 error. Okay, so guess what? Whoever is controlling the hypothesis test will control the probability of these errors happening. This is critical. Watch this. Okay, see, look here. For that reason, it's important to understand the mechanisms. You already know this, that the probability, the p-value, is the probability of getting your particular sample or something more extreme. We already had talked about this last chapter. Something more extreme if the null hypothesis is true. So look at this thing called alpha, and we actually already talked about this on our last notes that we just mentioned. When we look here, you see this blue section? This blue section is the size of the rejection region. So in this case, if the null hypothesis is true, and you reject, then what's happening is this is the probability of a type 1 error. Probability of a type 1 error. Why? Because the size of this area, if you get a sample in this area, you reject the null hypothesis if it is indeed true. You reject a true null hypothesis. Okay? So what controls the size of this blue area? Well, alpha. Correct. So alpha controls the size of that rejection region. Okay? So let's see what we want to put in here. Let's discuss the probability of type 1 error. This occurs when the null is true. So let's draw our picture here. We have the null is true. We've got alpha happening, and this is our rejection region. So this right here is where a type 1 area occurs. Where a type 1 error occurs. So then what happens is the size of this alpha is the probability of a type 1 error. So if you were the one in charge of the test, If you are paying for the test and you don't like a type 1 error, then what you going to do with this type 1 error size? If you don't want it to happen, so what you going to do with it? You're going to probably shift alpha so that the rejection region is smaller. If you are paying for the test, how is that doing that? If you are paying for the test, okay, if you're paying for the test and you don't want it to happen, I can do it better with this one. If you are paying for the test and you do not want a type 1 error, then you are going to control alpha. Watch this. I can shrink the size of the type 1 error, the probability, by shrinking the size of alpha. Okay? So there you go. So that's important. So if you go to a job and you don't want a type 1 error to happen, then you demand that you want that alpha to be smaller. Okay, let's do the next one. Here we go. The next one is type 2 errors. Let's discuss the probability of a type 2 error. This is occurring when the null is false. So let's draw our pictures here. This is important that I'm making you draw these more than once because it's important you understand the anatomy of these pictures. The null is false. So what do you have to say about the data? The data is not actually here. It's not centered around this here. Where is the data actually? If the null is really false, then here's where all your data is. Okay? So all your samples should be happening around this green curve. All right. But here's our alpha. Here is the rejection region. So you can see there are plenty of samples, many samples, all of these ones here, because the data is all out here, that are going to lead me to reject the false null hypothesis. But if I'm getting a sample right here, then that is going to what? Fail to reject it. So this size, this area right here, is the probability of a type 2 error. And that has a letter. That is called beta. It's like a capital, it's a Greek letter beta, but it kind of looks like a capital cursive B. You can see it right here in type. Okay, probability of a type 2 error. Now, let me show you that on my little applet. Okay, so here's this. Let me show you the alternative. Look here. So do you see this peach area? Do you see this peach area? That is the probability of a type 2 error. What if you are paying for the hypothesis test and you do not want a type 2 error? You want to make then this peach area what? Smaller. What do you think you need to change to make this peach area smaller? Yeah, watch alpha. Alpha is getting larger, and what's happening to the peach area? Smaller. So, can you tell me the connection between type 1 and type 2 area? Watch this. As type 1 goes up, as type 1 goes down, what happens to type 2? Okay? What happens as type 1 goes up, then type 2 goes. So they are completely opposite of each other. They are directly related, and alpha controls the size of both of them. Okay? So in summary, and then we'll stop for today and talk about this thing called power tomorrow. So in summary, and I don't really have a spot for this, alpha controls type 1 and type 2. Okay? And those two things are inversely related. As type 1 goes up, actually, look, we could write this. Ready? Alpha goes up, What does type 1 do?
Go down. Okay.
Okay, you don't know, so let's look at our picture. Alpha gets bigger. Type 1 gets bigger. Alpha and type 1 are doing the same thing. Alpha gets smaller. Type 1 gets smaller. Okay. So alpha gets bigger, type 1 gets bigger. And then what happens to type 2? Yes, type 2 always does the opposite of type 1. Okay? And alpha and type 1 are always going to do the same thing. If one goes up, the other's going up. If one goes down, the other's going down. And type 2 will do the opposite of it. Okay? All right, so that's all for today.